We will now go over the steps on how to set up the starter files in Greenfoot. First, we will navigate to our downloaded starter file, which is finchdemosensor.zip. We will then unzip this file and navigate to the unzipped folder. In this folder, you will find a Finch starter file, which contains our Greenfoot project. Also in this folder, you will see all of the classes that we plan to use to demo all of the sensors. You will see our red light, green light class, our light Finch class, and also our car Finch class. All of these will be demoed to you. We will double-click our project.greenfoot file because this file contains a reference to all of the other classes and ties them together. After our Greenfoot file opens, you will see all of the classes listed on the right-hand side. In this tutorial, we will explore a few of the sensors that the Finch robot has to offer. First will be the ultrasonic sensor, which detects objects in the way of the Finch robot. This is also known as an object detection sensor. Here we have your Greenfoot window. The large part of the screen is considered your Greenfoot world. This is where any interactive portions of the program you have will display. To the right, we have our world classes and also our actor classes. The three we'll be working with is red light, green light Finch, and car Finch. Below that we have our compile button. We will first start by double-clicking the red light, green light Finch actor class. We will then resize the window so that you can see all of the code that this class contains. All of the classes that we will be working with will be written in Java. We will not go into much detail on the code. The class's name, of course, is red light, green light Finch that extends actor. Extending actor allows the class to do whatever the red light, green light Finch wants to do. This method is called whenever the act or run button gets pressed in the environment, as we saw in the previous screen. The act method is called anytime we press this button, so that's where we want to put most of our code. In this method, we have our if statement. This is ran once the act method is called. It says, if the Finch's left sensor or the right sensor is not hit, then the wheel speed will continue to move forward in the speed of 25, and the Finch's LED will be green. In any other case, the Finch's wheel speed will be set to 0, which means it will stop, and the LED will be set to red. So essentially, if the Finch detects an obstacle in front of it, it will stop. Otherwise, it will go, similar to the game red light, green light, hence the name. Although we have our whole class spelled out, in order to run this class, we must first add it into the world. Now, because we are working with 3 projects, we must first comment out the ones that we won't be using in this case. So I uncomment red light, green light Finch, and when the world is ran, it will actually add that object onto our world. We will now compile and run this program and see how the Finch behaves. In order to run the program, we will first close our Finch World screen out. As you can see, because we made changes to Finch World, it has diagonal lines through it, which means it has not been compiled. In order to compile it, it will check it for errors and then compile it if there are none. So we press the compile button, and because there are no errors, you will see the green light come up on the Finch World, which means our program is ready to run. We will then press the run button and watch our program work. Did it work for you? If not, please go back and try our instructions again. Here is an example of how the Finch should behave after it has been programmed correctly. The next sensor that we will be looking at is the light sensor of the Finch robot. This sensor determines whether or not a light is being shown on the Finch and determines its behavior accordingly. We will first start by taking a look at the Light Finch class. We will double click it so that it opens up in our window. In this class, we have many of the same things that are in our red light, green light Finch class. For this class, you will have to turn off the lights, but the Finch will move forward until the light hits the target. The light Finch, of course, extends actor, just like in the last one, and we also have an act method. It starts off by setting the LED of the Finch to nothing, so it turns it off. Then, if the light level that the Finch senses is above 60, then the wheel speed will stop, and also the Finch's nose will turn to red. If anything else happens, then the wheels are just going to move forward in search of the light. Now, in order to test this, we will first have to go to our world and turn on our Light Finch class. When we open it, you will see that our red light, green light Finch class is already turned on. So we'll have to comment this out so that it's turned off and uncomment the Light Finch class. That will add it to the world. We can then exit out of the Finch world, compile our program because we made a change to the Finch world. After you compile it, you can see that it is the program that is loaded within the world because of the light bulb. You then press Run and watch your program. Did it work for you? If not, please go back and try our instructions again. Here is an example of how the Finch should behave after it has been programmed correctly. Class, we will be demoing the Finch motors. In this tutorial, you will see how the numbers that correspond on the Finch robots forwards and backwards actually move the robot. We will first start by opening up the Car Finch Actor class. When looking at this class, you can tell that it is very different from the two other classes that we were working with previously. Here we have the use of something called variables. Carfinch, of course, extends actor, and all of our variables are listed after. We have the variable name font and also speed. These are items that will be displayed on our window as the program is being ran. Here we have what is called a constructor. Within our constructor, our variables are set to different aspects. So we have font that is set to a new font, which is going to be the writing on the actual world. And the image is also set to that font that we are creating. Here we have something that we're a little more familiar with, our act method. Within our act method, Greenfoot is going to get whether or not a certain arrow key is down. If the up arrow key is down, then our speed is going to increase. If it is down key, then it's going to decrease. The speed must also be less than 100 or greater than negative 100. Also have, if the space bar is pressed, we're going to honk. At the bottom we have our image clear and the image drawing, which makes our world screen change to the different speeds that we will see on the Finch robot. So we're going to go ahead and close down this screen and go ahead and activate our Finch world. Here we have our light Finch that is activated, so we're going to deactivate that one and uncomment our car Finch so that we can add that object to the world. We're going to close that down, and as you can see, our Finch world is once again uncompiled, so we're going to press our compile button, and then we're going to go ahead and run our program. Did it work for you? If not, please go back and try our instructions again. Here is an example of how the Finch should behave after it has been programmed correctly. Thank you for watching this tutorial. Although we did not dive into all of the Java aspects that are necessary for running a successful Greenfoot project, we will do so in our next tutorial, so please be sure to watch.